I have explained the 5 basic steps a student should know, should follow in order to be able to balance a chemical equation easily. It is now time. We are going to balance the chemical equation for some reactions. Here on the board, we are starting with writing a balanced chemical equation for the reaction between sodium and chlorine. Alright? So we're going to write the chemical equation when sodium reacts with chlorine. At this point in time, I want to believe that you should have learned your first 20 elements and of course known the symbols of these elements. And also I want to believe that you've done your work on valencies, because we need this knowledge to be able to write this equation. So are you ready? Now let us answer this question on the board. We are going to write a balanced chemical equation for the reaction between sodium and chlorine. So how do we go about that? The reaction is between sodium and chlorine. So this is what we do. Sodium, you're going to write the correct chemical formula for these elements. The reactant here are sodium and chlorine, okay? So for sodium, the correct chemical symbol for sodium is Na. Is that okay? It's Na. Now this sodium is going to react with chlorine. It's going to react with chlorine. Is that okay? Sodium is a solid. The state of matter of sodium is solid. So I'm going to put S under here. Then chlorine is diatomic. Chlorine is diatomic. Let me mention this quickly. You can quickly put it down. Hydrogen is diatomic. If you see hydrogen anytime in a chemical reaction, standing alone, it will have H subscript 2. That is H2. Oxygen is diatomic. You see it as O2. Nitrogen is diatomic, you see it as N2. Fluorine is diatomic, you see it as F2. Chlorine is also diatomic, so you see it as Cl2. So I'm going to write this as Cl2. Chlorine is a gas, so I will put G, the state of matter there. I've been able to correctly write the chemical symbol of sodium and chlorine. So I'm going to put my arrow to show the product. I hope you're following. Now the question is, when sodium reacts with chlorine, what do we expect to form? And so we will take our mind back to the study of valency. Please, I encourage you to watch the video on valency. Okay, we've treated that already. Watch it so that you can be able to follow through with this class. Now, sodium, when it reacts with chlorine normally, what you would get is sodium chloride written as this. Sodium chloride. Sodium chloride is a salt, solid in nature. The state of matter is solid, so I will put S here, solid. This is how sodium chloride compound is written. This is the correct chemical formula of sodium chloride. And I got to know this from my knowledge of valency, which I have given to you, and I believe that you also are aware of that. If you interchange the valencies of sodium and chlorine, you would get sodium chloride written as NaCl. Now you notice something from the reactant. This is the reactant, sodium plus chlorine. Then the product is sodium chloride, a compound, new compound formed. You would notice something. Look at the reactant. How many sodium do we have there? 1. So you go to the product and you check the number of sodium you have there is also 1. So sodium is balanced per se. Remember, we have finished step 1. Step 1 is writing the correct chemical formula of the reactant and the product. So step 2 is now to check each atom if the number of atoms of the elements are balanced. Is that okay? If you come to sodium, how many atoms do we have there? 1 atom. Normally, sodium is written as Na. Now, there is no number here, if you see. There is no number down here. So it means it's 1 atom. And if you come to the product here, it's 1 atom as well too, because there is no number here. So you have invisible 1. If I fix up any number here, just before this sodium chloride, that number is number of molecules. I said that about oxygen when I introduced XO2, you remember, right? Good, in our previous video. So the number of molecule here for sodium chloride is also 1. That is why we didn't put any number here. There is no number here. Invisible 1. So sodium is balanced. 1, 1. 1 in reactant, product 1. But what about chlorine? Normally, chlorine as a gas is written as Cl2, not Cl. Cl is just the atom of chlorine. But in nature, the way chlorine exists is Cl2 as a gas. So, if you look at the product, how many chlorines do you have here? You notice that there is no number here. So it's invisible 1. And the number of molecules here is also 1. If you do 1 times this invisible 1, you still get 1. So in the product, chlorine is 1 atom. But in the reactant, chlorine is how many? 2. So I'm going to ask you this question. Is chlorine balanced? 2. On the reactant, 1 in the product. Of course, it's not balanced. So we are now going to try balancing chlorine. So what do? We will now move on to the next step because we want to balance it up now. We found out that something is wrong with chlorine. So I am going to attach a variable, an unknown, as number of molecules to the compound where chlorine is found at the site where the number of chlorine atom is lower. Remember, step 3. Alright? Step 3. Now, the product side, you see that chlorine is 1 atom. Reactant side, chlorine is 2 atoms. So the sign that chlorine has a lower atomicity is in the product side. Therefore, I will come to the product side and then I will fix up X as number of molecules. Now this number of molecules is affecting both sodium and chlorine. Remember, you always fix that number of molecules if you are attaching the variable. So we will now calculate X. We will solve X and see what happens. And how do we solve it? Remember, we are solving for chlorine. So, I'll write solve for X to balance chlorine. To balance chlorine. I'm writing this as a guide. When you are doing it yourself, you don't need to write this. You can just do it as a rough work. So how do we balance? You use the knowledge of simple equation in mathematics. This is the left-hand side of the equation where you have the reactant. This is where you have the product. This arrowhead, the arrow pointing to the product, is like equal to. So you come to chlorine on the left-hand side. How many molecules of chlorine do you have here? 1 molecule. There's invisible 1 here. So 1 times 2 would give you 2. Is that not so? On the left-hand side. So I'm going to do 1 molecule of chlorine times 2 on the reactant. 1 times 2 on the reactant. The arrow here is equal to. Now how many atoms of chlorine do you have in the product now? Remember, you have X molecules. Whenever you have number of molecules, it's affecting everything in that compound. So this X belongs to sodium. It also belongs to what? Chlorine. But here, the number of atoms of chlorine is 1. So you do the number of molecules, which is X times 1. So it's going to give us X times 1. Therefore, you would see that 1 times 2 will give us 2, and X times 1 will give us X. So we've gotten the value of X. Therefore, X is equal to 2. Now that I've gotten X equal to 2, I will rewrite this equation again. So, rewriting the equation. As I'm rewriting this equation, remember I introduced X here. So I'm going to fix in the value of X I got. I'll write every other thing to remain the same. So we go. Sodium, which is solid, plus chlorine, which is a gas, a diatomic gas. Now we have X, sodium chloride. That X is what? 2. So I'll fix it. 2 of sodium chloride was formed. 2 sodium chloride solid. Now chlorine is balanced. Because in the reactant side, chlorine is 2. 1 molecule times 2 will give you 2. In the product side, chlorine is 2 times 1 atom of chlorine. Is that not so? I told you that this 2 is affecting everything, all the elements in this compound, because it is number of molecules. So you have 2 times 1 for chlorine, which is 2 on the product side. Chlorine is balanced now. But unfortunately, there is a problem with sodium now. The reactant of sodium is still 1. But I told you already that this 2 is number of molecules, so it's affecting everything here. It means that sodium in the product is now what? 2. So let me ask, is sodium balanced with this equation? Answer is no. So we try to balance for sodium. And to balance for sodium, what do? I will need to attach a variable to the side of sodium where we have the lower atomicity of sodium. So I ask you, sodium in the reactant is 1 atom. In the product, it is 2 atoms. So where do we have the lower atomicity? The reactant. So I will fix an unknown there. Let me use Y as number of molecule. Don't put it here. You don't do that. Sodium is always Na. 1 atom here. What you are attaching, the variable you are attaching is always number of molecules. So you write it just before where you want to put it. Good. Now you now have Y molecule times 1 atom of sodium. Then I'm going to solve for Y. Solve for Y to balance. To balance sodium. To balance sodium. And so to do that, this is what we are going to get. Y times 1 atom of sodium will now be equal to, take note that here the number of atoms of sodium here is 1, the atomicity. Then if you do 2 molecules times 1 atom of sodium, it will give you 2 atoms of sodium in the product. So 2 times invisible 1 atomicity of sodium. So Y times 1 will give us Y equal to 2 times 1, which is what? 2. So you have gotten the value of Y. Next, you will rewrite. Okay, let me use blue marker to write it. Y equal to 2. Good. So I'm going to rewrite. Rewrite the equation. You know, with Y equal to 2 that you've just gotten, this Y equal to 2 you've just gotten, simply shows that sodium is balanced, because it was because of sodium that you calculated Y, since you attached the variable Y to sodium there. So if I fix 2 for Y here, it means that sodium is balanced. I'll now check if this calculation affected chlorine. If it affected chlorine, I will still find a way to balance chlorine. But let us see if it's going to affect it. So in rewriting the equation, we're going to have 2 molecules of sodium. That is 2 molecules of sodium. And it is solid, we know. Then plus chlorine is diatomic, a gas. Now it gives us product to be 2 molecules of sodium chloride. Sodium chloride, and this is solid. So let us take a look at this and still check if the atomicity of everything now is complete. Sodium, 2 molecules times 1 atom gives us 2 atoms altogether. Then the product, you notice 2 molecules times 1 atom of sodium will still give you 2 atoms of sodium altogether in the product. So sodium in the reactant is 2 atoms, sodium in the product is also 2 atoms, it's balanced. Let's check for chlorine. 1 molecule of chlorine times 2 atoms in the reactant would give you 2 atoms of chlorine in the reactant. In the product, 2 molecules of sodium chloride, you know, that 2 will multiply 1, which is the atomicity of chlorine in sodium chloride. 2 times this invisible 1 here will give you what? 2. So chlorine in the reactant is 2, chlorine in the product is what? 2. Therefore, this equation is balanced. Do you like what you see there? It's very simple. So okay, all you need is just, you know, a good knowledge of your simple equation, and that's all. Now, if you like what you see here, don't forget to talk about the GMAETS 41 Support Student Education Initiative, inform your friends, share our videos, tell them to contact us, and get enrolled in the program, okay? Just contact us and join our classes. In this video, let us write the balanced chemical equation for the reaction between hydrogen and oxygen to give us water. So what we do, I'll be fast now, because in the previous video, I have taken my time to explain step by step how you write a balanced chemical equation by solving simple equations. Please come with me, let's see what to do here. Write a balanced chemical equation for the reaction between hydrogen and oxygen to form water. So the first thing we need to do is to write the correct chemical formula for the reactant and the product. So here, hydrogen is reacting with oxygen to give us water. So this is going to be hydrogen. Hydrogen is diatomic. So when you say diatomic, it means it has two atoms. It's a gas. So I'll put G here to represent gas. Now it's reacting with oxygen. Oxygen is also diatomic. So it's going to be O2. It's a gas as well too. I listed them in the previous video, the diatomic gases in our first 20 elements. So you have your arrow pointing to the product. When hydrogen and oxygen react, mostly we get water. Of course, we've been told that it forms water, so I'm going to write H2O. This is how water is being written. This is the correct chemical formula of water. Take your mind back to our class when we treated valencies, okay? You get to know that this is the correct way of writing water. I will put liquid here, okay? Let's take the state of water here to be liquid. Now, let us take a look if the atoms of the elements in this reactant and product, if they are balanced. Starting hydrogen, these two atoms, one molecule times 2. So 1 times 2 will give you 2 atoms of hydrogen. In the product also, this water is 1 molecule, because normally this is how water is written, H2O. So it's 1 molecule. 1 times 2 atoms of hydrogen will give you 2 atoms of hydrogen in the product. So we have 2 atoms of hydrogen in the reactant, 2 atoms of hydrogen in the product. It's balanced. We now move on to that of oxygen. In the reactant, we have 1 molecule times 2 atoms of oxygen, and 1 times 2 will give us what? 2 atoms of oxygen in the reactant. Now look at the product. 1 molecule of water times 1 atom of oxygen. You know that the atomicity of oxygen in water here is 1. So the 1 molecule here times 1 will give us 1. Now in the reactant, oxygen is 2, but in the product, oxygen is 1. Therefore, is oxygen balanced? That's correct. Oxygen is not balanced. So we try to balance it. What do? Look at this reaction equation. Where do we have the lower atomicity of oxygen? It's in the product, which is 1 atom. So I will go to the product. The number of molecules for where oxygen is part of, I will fix X there, which is the variable. Then I'll calculate X. So what do? I'm looking for a way of balancing oxygen atoms. So I will focus on oxygen in the reactant with oxygen in the what? Product. So we go. Balancing up, if you come here, 1 molecule of oxygen times 2. Balancing oxygen. So in the reactant, you have 1 times 2. 1 molecule times 2 atoms. Then going to the product, you have X molecules times 1. You know that this X is affecting all the elements in this water. So times 1 atom of oxygen there. You take it, note that 1 times 2 will give you 2 equal to X times 1 will give us what? X. Therefore the value of X is equal to 2. We are now going to rewrite this equation. Rewrite the equation. Now in rewriting it, I'm going to have H2, so this is gas, plus oxygen O2, this is also gas. Now the product is going to give me is 2H2O. You know we calculated X to be equal to 2. So this is liquid. Now if you take a look at this, you notice that hydrogen is no longer balanced. In the reactor, hydrogen is 2. 1 molecule times 2. You get 2 for hydrogen. But in the product, you have 2 molecules times 2 for hydrogen, which is 4. Is that not so? Which is 4. So there is a problem there with hydrogen, it's no longer balanced. Oxygen is now balanced. 2 atoms here in the reactant, then 2 in the what? Product. Because this 2 is affecting the oxygen as well too, and then the hydrogen. So let us balance out for hydrogen now. So let us see what this is going to give to us. We have 2 atoms of hydrogen in the reactant, 4 in the product. So atomicity of hydrogen is lower in the what? Reactant. I'll go there and fix a variable, let's say y, in the number of molecules. So I'll now do y times 2, right, will now give us equal to, go to the product, 2 times 2 for hydrogen. and then you can divide both sides by 2. You know, this y times 2 give you 2y equal to 2 times 2, which is 4. So if you divide through by 2, the coefficient of y, you get y to be equal to 2 times 2 divided by 2. In mathematics, if dividing something is possible, divide before you multiply. Rule of board mass. It helps you to be working with smaller numbers. If you multiply, you get a bigger number, which the division might just stress you. So from here, you notice that these 2 and these 2 we cancel. Therefore, the value of y is equal to what? 2. Now, rewrite the equation again. Rewrite the equation. So we're going to rewrite and then check. Here we have y is what? 2. So 2 molecules of hydrogen gas, then reacting with oxygen gas. This gives us the product, 2 molecules of water, H2O, liquid. So let us check, is it balanced? Hydrogen in the reactant now is 2 times 2, which is 4. The product, 2 times 2, which is 4. Oxygen in the reactant is 1 times 2, 1 molecule times 2, which is 2 atoms. Then the product is 2 molecules times 1, which is also what? 2 atoms. So what does that mean? This is balanced. So you can put it there, balanced. So you can see how we do that. Pretty simple. When you cut and put sodium solid particles in water, these solid particles of sodium, we call it sodium pellets. If you drop it in water, these sodium pellets will start moving about the surface of water. We refer to that as dart, D-A-R-T. The sodium will start darting about the surface of water and reaction will start. In a short while you will see something coming out, a gas. That gas is hydrogen gas. In the process, the sodium will start melting. Now we are going to write a balanced chemical equation for this reaction when sodium reacts with water. Come along, let's see what we do. Remember the first thing, write the correct chemical formulae of this reactant and the product that's going to be formed. So we go sodium, Na, it's a solid, I said that already, so we put a state of matter, and sodium naturally is written like this. Is that okay? Now it's reacting with water. Water is liquid. Now the product we are going to get is what? Let us look at what is going to form here, okay? Do you still remember that in water there is a radical in it? The radical in water is OH. The radical in water is what? OH negative. Water usually contains H positive, which is cation, and then OH negative, which is anion. When they attract and interchange their valencies, it forms water. So, during the reaction, sodium will pick the OH negative part. Because sodium is positive, you remember from valency, sodium is positive. Now in water we have OH. OH is negative, so there will be this attraction. Opposite charges will attract. When that happens, we are going to get sodium hydroxide. Sodium hydroxide, in this case, will be in a form that we call aqueous. Aqueous is a chemical liquid, is that okay? Refer to it as aqueous. Now, this is going to release hydrogen, like I said, because from this water it is OH that was taken by sodium. H is still there because OH, which is negative, plus H, which is positive, when they react, will give us H2O. So that hydrogen will be given off as a gas. I know that if hydrogen exists on its own, it exists as a diatomic substance. So that's going to be H2. Now let us check if this equation is balanced. For sodium, in the reactant it is 1. In the product you can see clearly that it is also what? 1. So sodium is balanced. Hydrogen. Hydrogen in the reactant is 2. In the product, watch out. In this sodium hydroxide, how many hydrogen do we have? Only 1. Then look at plus here, like you do normal mathematics. This is plus. You're going to add it to how many hydrogen here? 2. So if you do 1 hydrogen plus 2 hydrogens, you get 3 hydrogens. In the product, hydrogen is 3. In the reactant, hydrogen is what? 2. So hydrogen has a problem here, it's not balanced. Okay, oxygen. Yeah, oxygen is balanced. We have 1 atom in the reactant, 1 atom in the product. So what are we going to do? Let us balance the hydrogen, because that's where we have problem. Alright, balancing hydrogen. Now there was something I said, step number 5, when I gave the rules, the steps for balancing a chemical equation. Step 5, I stated that when you have a single gaseous element that is given off during chemical reaction, that element is treated independently. So look at what happened here. Hydrogen gas is given off separately. So we're going to treat this H2 separately. Let it be there. We wouldn't touch it. We'll come to this part. Now why we don't have to touch this is we can play around this H2 anyhow we want. Yeah, I can choose to add up any number of molecules. Here's my choice to balance up anything. So I don't have problem here yet, since it is only H2 that I have, the only hydrogen. Let it be there. I will go to where I have hydrogen again, combined with other elements. Because whatever happens to hydrogen then may just affect something. I'll focus here and try to balance with this hydrogen. I'll balance the hydrogen here in sodium hydroxide in the product. I'll balance it with the hydrogen in water in the reactant. So let us do that. 1 molecule of hydrogen times 2 atoms, 1 times 2 will now give us equal to, in this case, I'm going to attach X here. You know, because hydrogen atom in the product, in this case, is lower. Are you following, right? It's lower than the hydrogen atom in the reactant. Remember, I have said we are keeping this aside. When we try balancing this and we have issues, we can now come here and do some, works. But for now, let's keep this aside yet, as if it doesn't exist there, and see if we can balance up this part. So X molecules times 1 atom of hydrogen, X times 1. So you see that 2 will be equal to X. This simply means that this number of molecules, the variable we put there, X, is equal to 2. So I'm going to rewrite this equation. Now if I'm rewriting the equation, I'm going to get sodium solid reacting with water, H2O, liquid. Now the product is sodium hydroxide. We got X to be equal to 2. So that's going to be 2 molecules of sodium hydroxide. This is aqueous, then plus hydrogen gas, H2 gas. Now if you take a look at this, hydrogen is not balanced yet, because in the reactant we have 2 atoms of hydrogen now. In the product, here in sodium hydroxide we have 2 times 1 atom of hydrogen, which will give us 2 atoms altogether. Then plus, here we have 2 atoms as well too, because this is 1 times 2. So the 2 here plus the 2 here will give us 4 atoms of hydrogen in the product. But in the reactant we have 2 atoms. So we can easily balance up. But let us check for that of sodium first and see an oxygen. Because we have problem now, sodium is 2 here, oxygen is 2 in the product. But in the reactant, they are both 1, 1. So let us balance up for sodium and possibly for oxygen first, before we start talking about hydrogen again, if necessary. So the number of sodium in the product here is 2, but in the reactant it is 1. So the atomicity in the reactant is lower. I'll come here and then put an unknown. Okay, let's use Y. We've used X before. Let's use Y. So Y times 1 atom here will now be equal to 2 molecules times 1 atom of sodium here, which is 2 times 1. If you work on this, the value of Y is going to be equal to 2. So I will rewrite I'll still rewrite the equation. So if I'm writing the equation, y is 2 now, so I'll put 2 sodium, 2 molecules of sodium, a solid, plus H2O, liquid. So this is going to give us 2 molecules of sodium hydroxide, aqueous, plus H2 gas. Sodium is now balanced. 2 atoms in the reactant, 2 atoms in the product. We are left with oxygen and hydrogen still. Like I said, let's work with oxygen first. We've touched hydrogen before, so we'll leave hydrogen for now. If necessary, we'll come back to it later. So balancing oxygen, because oxygen is not balanced. Balancing oxygen, let's see what we get. In the reactant, oxygen is 1 molecule times 1. Which is going to give us 1, but in the product, it is 2 times 1, which is 2. 2 molecules of this sodium hydroxide times 1 atom of oxygen. So in the product, oxygen is 2, in the reactant, oxygen is 1. So where do we add our variable? We'll add it to the reactant. Which variable would you like me to use? Okay, let us use A and C. I'll put A here. I'll put A. Okay, so this is going to give us, or should I change it to C so that it doesn't look like 9 to anyone? So let me put it C. So this is going to give us C times 1, that is C molecules of water times 1 atom of oxygen. That is going to give us 2 molecules of sodium hydroxide times 1 atom of oxygen, which is 2 times 1. Don't forget, the number of molecules affect all elements in the word compound. So C is now going to give us 2, because C times 1 is C. Equal to 2 times 1 here is 2. So I will now rewrite the equation. Let's see what we're going to get. Rewriting the equation, you come over here, you have 2 molecules of sodium. 2 molecules of sodium is solid, reacting with C is equal to 2, so it's going to be 2 molecules of water, H2O, liquid. Now this gave us 2 molecules of sodium hydroxide, 2 molecules of sodium hydroxide. It's aqueous, then plus H2 gas. Now oxygen is balanced now. So sodium is balanced, oxygen is also balanced. Let's revisit hydrogen and see what happens. Hydrogen here is now 2 times 2. 2 molecules of the water times 2 atoms of hydrogen will give us 4 in the reactant. Then in the product, look at this side. 2 molecules of sodium hydroxide times 1 atom of hydrogen will give us 2 hydrogens here in sodium hydroxide. Then plus, how many hydrogen do we have here? 2. So 2 here plus 2 here will give us 4 atoms of hydrogen in the product, which is the same as 4 atoms of hydrogen in the reactant. So everything is now balanced. Okay, so let me write that. Balanced. So you can see how we have been able to write chemical reaction equations and balance them. Now next class we'll see for other compounds, where we deal with radicals more. Until then, remember, talk about the GMAETS 41 Support Student Education Initiative Program. Invite your friends to contact us and enroll in this special class that is arranged to improve your background of science and mathematics.